So, welcome everyone. I thought when I saw that there's going to be a Ceph Day here in London that it might be a good idea to talk to you about what we do at IBM Research, especially since it's always the research firms are always tight-lipped about what we're working on, right? And what IBM wants to do with Ceph, because I think it could be a major vendor jumping on this software-defined train, but I don't want to tell you anything about the marketing side, right? I'm not a marketing guy, so. We have a legal disclaimer, thanks to our lawyers. So whatever I say here is non-existent, okay? And it doesn't give you any right to whatsoever. Well, I had to do that, sorry about that. So what are we going to talk about? I'm going to talk to you about what we do with the Ceph at my workplace, which is the research lab in Zurich. And then a soft layer, which is a cloud company acquired by IBM last year, and then what we want to do with Ceph in the future, which involves contributing code back to the community. So hopefully we're also going to jump on the train and become upstream contributors, provided our lawyers agree. So was the Zurich Research Lab. It was the second research lab IBM opened. I'm very proud of the fact that I actually worked there. You'd be surprised, but 80% of the people working there are physicists. So the IT staff is really small. And I don't belong to the IT guys, so if you have a broken laptop, you don't call me. I'm actually in the Cloud Solutions group. So we're looking at what to do with scale-out storage, what to do with the cloud if people want cloud, because people do want clouds, right? They want to build their own, they want to jump on it. What could we tell them? Okay, that's going to be in 5 years. So it's... And for these guys, the researchers who are looking at what to do with cloud, obviously they need the cloud to play on, right? And for legal purposes, Switzerland has a very strict data retention law, so some of the data we can't even export from the country. And second of all, with the volumes we have, which is for easy experiments, it could be 30-40 terabyte, we can't just take it, upload it to soft layer, which is the nearest data center is in Amsterdam. So we need the local DC with the local equipment, the local cloud, and to give people a portal where they can just jump on, create a VM. If they need 10, if they need 100, they just go there, do their workload, do their whatever experiment they want, and be happy with it, right? So we don't have the usual end users because they always have special needs, sadly, and they always need their own special software. So actually they can upload any image, they can run any software image in their VM, so we don't restrict it in any way, okay? And we started doing this around 2 years ago, went into production a year and a half ago, and now we're at the second iteration. But what did we start with, right? We started really small. We had these 3 compute nodes with 14 terabytes of SSD storage, connected with dual 10 gig, and we were really happy with it, okay? So at that time, I don't know how many of you run OpenStack. Show hands. Okay, not so many people. So the main use case for us is OpenStack with Ceph. The OpenStack is the focus, and we didn't want to, invest into big storage. Although IBM do sell storage, it's even for us internally, it's a cost, right? So if you want to spend $500,000 on storage, we need to come up with that money somehow. Instead of that, we thought, oh, we have this hardware around, why don't build something, right? And we had some Supermicro boxes. That's not surprising given that soft layer is all Supermicro. It's not running on IBM hardware. And we put together something. I don't know if I don't have a picture of it, but regardless, at that time, what you have to know is that there were a lot of OpenStack integration issues. So there were like 20 patches that you needed to apply to that back release of OpenStack, which is Havana, to actually get it up and running and working with Ceph. But we did it at the cost of not being able to upgrade, right? So that was a major pain. And then people started to jump on it, and we have this graph from Moonin. You can see that basically what people did, they had very small I/O jobs, and actually they started running Hadoop jobs, they started running their own God knows what, because the VMs are black boxes, and our storage need just started to grow. So we decided to do a second iteration, right? The network was doing fine. So with dual 10 gig, we actually did not have any network issues in terms of contention or performance or whatnot. The biggest issue was the actual hardware being sometimes down, right? Yeah, so we needed to replace switches. But we never actually had any issue caused by the software to be done, right? One issue that we run into, and which was already mentioned today, is we run out of space on one of the OSDs. And then so what Ceph does when you run out of space on even one of the OSDs, instead of being intelligent and writing the stuff to other OSDs, it just blocks all writes. Okay, so that's really, really bad for your VMs, and that time you need to make some space available somewhere or expand. That's how we grown from 16 SSDs original to 38, because we started shuffling in new SSDs all the time, right? And then we started looking at how could we grow, how could we give users the ability to actually store more data than they want. So what we did, we built these systems. We have 6 of these. This is one rack. We have 2 racks, full independent power, network, whatnot. And what we did here is we have 12 times 2 terabytes of disks in each node, with backing SSDs with the 1:4 magical ratio that everyone seems to be happy with, and I'm happy with it too. So we have 2 SSDs in the back that you cannot see, which host the OS, plus it has the slices for the journals. And we're not rating the journals, right? Why would you rate them? So 6 disk, oh no, in this case, sorry, it's 1 to 6. 1 to 4 is in the other case. So here it's 1 to 6, and we're still happy with it. So we partition the SSDs. Each OSD gets a slice of the SSD as its journal, and that's how we run. We have 3 monitors running in VMs, not on these hosts. We found it that basically the monitors are not resource hungry, right? You can run them on anything you found, anything you find in the company, that in a small desktop PC, whatnot. We're using VMs on SSDs. They really need SSDs. I think that's the based on what I've seen and what the CERN guys seen and what the community's seen. For the monitors, you really want to use SSDs, because otherwise, when you actually have an issue, you need to do backfills or you need to do a lot of cluster management. Your monitor will slow things down. So we went with SSDs there. And we actually shut down the previous cluster, so we have a bunch of 40 SSDs available now, which we want to repurpose here as a second pool in Ceph. Thanks to the crash map, right? You can really fine-tune how you want to store your data or which OSDs you want to put in. So what we're going to do when I get back to Zurich later this week, we're going to reinstall those nodes, we're going to put them in. And the user will have the ability, when they actually want to use storage, they will have the ability to select, oh, I want a lot of quota on a normal spinning Rust, or I want a little bit of quota on very fast SSDs, right? But then, of course, you're going to hit some small I/O block problems in Ceph that's being worked on, and will be much better in the next release. So that's what we do with Ceph. We're quite happy with it. We'll need to grow soon because the users are eating up all the data. So it's almost done, the 130 terabyte that we have here. And we're going to buy again, this is the amount we settled in. So we're going to get 6 of these boxes again. So we're going to go to 260 terabytes and then up from there. And it scales beautifully. We haven't had any issues, okay? And now, given this experiment and given this experience we had at the lab, IBM decided why not put it on SoftLayer, right? So SoftLayer, oh, okay, I have it later. So IBM is growing in what we do with the cloud, right? We're part of the OpenStack Foundation, we're part of the Cloud Foundry Foundation. We're really trying to participate in an open source project around any cloud-related thing, and scale-out storage, and I believe Ceph is the basis of scale-out cloud storage. So we wanted to, bring the two worlds together, bring our enterprise hosting platform, which is now SoftLayer, and this technology together. So what we did, we'll start offering Ceph on SoftLayer as a service. It's not just Ceph, okay? It's a hosted, managed private cloud on SoftLayer, with Ceph used for volume storage. So you get the cloud from IBM, which is managed by IBM. The hardware is hosted by us. If you have any issues with any of the components, software-wise or physically, we're going to repair it. We're going to service you, right? And the best of this offering is that for whenever you add volume storage, you're going to get it from Ceph, right? And after lots of measuring and whatnot, we decided to do the 3 monitors in VMs, right? With 5 or 7 monitors, it just complicates the setup and doesn't really gain anything, right? So we decided you're going to have 3 cloud controllers running everything in VMs, including the Ceph monitors. So for example, your open cloud services, they are running also in VMs separately on separate physical machines. So you have high availability also for your database there. We're going to give you either 1 gig or 10 gig network connectivity depending on which data center you choose from. We don't have dual 10 gig available in all of the SoftLayer data centers yet, so that's going to take some time. When you board, you're going to have to choose your storage size. We're pretty conservative, right? So this is our first offering around Ceph. You know, IBM has GPFS, which is kind of competing, but we wanted to give this a go. So from 8 to 96 terabyte, this is very small in this regard. And when you board, you can choose what size you'd like, okay? And I'm omitting how many compute nodes you have with what memory and whatnot, because that's not really interesting from a Ceph perspective, right? And we decided to go with 2 times replication instead of the now recommended 3, right? It was changed in Firefly to go with 3 times replication. And I don't know how many people actually used it, but they have a reliability. It was mentioned as a Google Summer of Code project, but they have a reliability calculator. So how many guys have actually used the Ceph reliability calculator? Okay, 2, 3, yeah. So Ceph has this wonderful tool. You enter your details about your physical environment, like what's your failure rate in the disk, what's your unrecoverable read rate on your disks, and it's going to build a statistical model, and it's going to tell you, okay, I think this is going to be your availability, mathematically speaking, right? And if you put all of our details into that tool and you run it, you're going to get more than 99.9%, even with a 2-way replication in these setups, okay? And we decided that's good enough, okay? So, because in terms, if you want to go with 3-way replication, it's going to add a hell of a lot of cost, because you need to, again, replicate that amount of data. And you could say, why, okay, guys, why don't you use erasure-coded pools, right? It's already out there. And we don't use erasure-coded pools because we don't trust it yet. Okay, it's the same with the cache tiers. So, have you guys tried to run the cache tier code in the current Firefly? How many of you have tried to actually run it in machines? Yeah. So not so many again. So one of the drawbacks of the current cache tier iteration is that whenever you hit even a small part of a 4 megabyte chunk on your back OSD, it's going to pull all 4 megabytes in to the cache. So if you have a very diverse, not so cache friendly workload, you're going to actually slow down things and going to overload your Ceph tier, right? Or your cache tier, sorry. So so we decided that in this release that this is gonna happen soon. We're not gonna give you either erasure code, or we're not gonna give you caching yet. But these are all options, right? So what we do, we have a Ceph test lab at my workplace, right, at the research lab, where we constantly try out the trunk code in different scenarios and see what happens, right? And when we see a good result, we try to transfer it to SoftLayer so people can use the same. And you know, lots of good things has been said about Ceph today so far, but for us, right, and for the people using SoftLayer, cost is one of such options, right? You don't need to buy the big expensive storage arrays. It's enough that you just get your commodity, I wouldn't say desktop drives, because obviously you'd get enterprise SSD at least for your journals, but it's still a lot cheaper than buying the big storage vendors, even our own, right? And keep in mind that still SoftLayer, it's a very new acquisition, so they are using off-the-shelf hardware. They are using Supermicro, and Supermicro is not going to give you the super fancy, very expensive drives, right? Or that's not why you buy Supermicro. So that's what we're doing on SoftLayer. I think it's pretty exciting that you can get that. We have a 30-minute SLA and everything, so if your drive breaks, if our network gear breaks, whatnot, it's going to be replaced in 30 minutes. And then that's so far what we've done with it so far. And then let's have a look at the futures, because I think this is the interesting part. This is the part that we think Ceph is currently lacking, and IBM might be able to help, right? So one of the things that, okay, you mentioned you guys not really OpenStack users yet. You will be, but basically what happens is that when OpenStack accesses your Ceph storage, it uses a central token for the different OpenStack services. There's basically 3 services you want to keep an eye on. So Ceph uses 1 or 2 or 3 authentication tokens to actually access your Ceph pools, your Redis, your RBD images, and your Redis files there, right, or blocks. And that's not very security friendly, because you look at it and what's going to happen if someone gets hold of that key, right? So ideally what you'd like is that when you spawn a VM, let's say I start a VM, then that VM actually uses my own Ceph key to access my Ceph storage. And that's currently not there, okay? It's not even planned for OpenStack. There's no blueprints for it, not what. And on the Ceph side, it actually doesn't take much, because Ceph already has all the authentication framework places, or all the authentication framework pieces in it, right? So you just need to augment OpenStack to actually utilize this properly. The second thing that you currently don't have, if you have a virtual machine running in OpenStack and you're going to snapshot it, it's going to copy your whole virtual machine disk to your controller. It's going to do a raw image convert there. It's going to upload it again. And if you have 200 gigs of VMs, you can imagine how long this takes, even on 10 gig network, right? And especially since your controller is using small traditional disk. And there's an open bug for it in OpenStack. I've submitted a fix for this. It's currently being reworked and debated and whatnot and blogged on politics, but we'll get there. So this is planned for the next OpenStack release next April. So it's still a way out, but OpenStack has the 6 months releases, and they just released the newest version, Juno, on October 18, yeah. So the next version is going to happen in 6 months. And this 4 has been OpenStack, right? So the first 2 bullet points has been what OpenStack is missing. Now talk about what Ceph's missing. So imagine you have multiple data centers, right? So in software we have a lot of data centers. And ideally for disaster recovery, what you want is that, okay, I write my data here, but I have a, well, I would say a copy, right? But that's very expensive on the other data center. And if you look at NAS vendors, enterprise storage vendors, they're going to offer you metro clustering and they're going to offer you scale-out clustering, but they're often not going to tell you that it comes at a cost, right? It's going to limit your local I/O performance if you're doing synchronous replication over very high latency links. So what we'd like to add to or see in Ceph is that we can do async replication on selected operations. So write the local copy in the local data center first, then do an async write of the other parts in other data centers later. So this is currently not there, right? With the crash map, what you can currently do is you can set your data centers up, and then you can do a cross data center snapshot, and that's gonna, because it's a copy on write operation inside Ceph, that's gonna happen without blocking any of your local I/O, and it's gonna nicely write the data to the other data center. But that's, and for a lot of purposes that's enough. I mean, you could write a script that snapshots your data every hour or every 10 minutes or whatnot. But for a more smoother experience, what you'd like to have is just you tell, okay, replicate this there, and it should happen automatically, right? The other thing which comes here is that if you have multiple Ceph clusters, how do you manage them currently, right? So your Ceph tool doesn't support multiple data centers, and there's no way to actually give the semantics of a data center to Ceph. It knows the syntax via the crash map, but it doesn't know the semantics. So what you usually want to do, or you would like to do in an ideal world, right, is that the Ceph command line tool would have actually the semantic meaning of what a data center is. And you should be able to say, okay, I have 3 monitors in this data center, 3 monitors in this data center, and manage your cross data center linkage via the same command line tool, right? So this is something we feel like we need in Ceph. So the current developer summit is very, very close to actually write the blueprint and get all of this there. So maybe after the next release, we could see this in Ceph upstream, right? At least I would very much like to see this upstream, because I think this is the last piece that's missing. If you look at the change, like everything's improving, right? There's a ton of changes going into the erasure coded, different type of erasure codes. There's a ton of change going into SSD performance or RAIDs, but I haven't seen any single commit that deals with multi-DC RAIDs or lower layers, right? Yeah, so that's the plan, right? It's again, it's not something we're committed to at this point yet, but we'll hope to see it one day. All right, so that's what we do currently.